Now this is part 2 in the sequence of videos where I plotted the COVID data. After getting the introduction, if you went through that video about what motivated me to create such a program, I thought that this program would make an excellent experience for students in CPSC 203, the non-major students, to have experience not just writing a program and problem solving, but doing so with actual data and relatively large data set. You can download here essentially a small portion of the Alberta Health Services data that is currently available. A4 COVID data now appeared in downloads. See, what I have here is I actually have the actual AHS information I downloaded earlier for part 1 of this video, 30 megabytes of information, raw data from the Alberta Health Services website for infections that snapshot to the beginning of December. And this is the, based on this data, I added a program here. This A4 COVID data, however, only contains a subset of that information. You can ignore, normally you shouldn't ignore that first warning about downloading something online, but this is something that I got from my web page. You shouldn't also ignore the second warning where you have macros, a program attached normally, but this is something I created myself, so I know it's safe. So we have in this spreadsheet here, each row is information about a person who was actually infected with COVID. And we have some of the demographic information, but it's anonymized to meet with FOIP regulations. So we don't have information where we can identify who it actually was, of course. We had previously here a run of my program, and I'll delete it so that you can see when I run the program again what data your assignment is supposed to produce. This is only a subset of the data that's currently available. So we scroll down a bit, page at a time. We have about 600 odd rows of data. One entry for April here. And what the program that you're supposed to write for the assignment is going to do is populate this with some information here and here. It will put a total for the number of infections that it finds in the spreadsheet here. Recall that each row is an actual person who was infected. For each person that's infected, we determine the current status. Fortunately, most of these people have recovered. Unfortunately, we also have cases where people have passed away. Notice that it's not in perfect alphabetical order. So we'll need to put it in order as well too. Let's look at what you need to do. So you can download this file, and it is a Excel spreadsheet that can contain a program. You have the ability now. Make sure you save it in, not in all open workbooks, but this current workbook. Or that file name. So we can give it a name. Probably give it a good name. Alberta COVID statistics, and then create, or I believe it's a plus icon in plus label in the Mac version. And now we have the ability to type in our macro. Although you're writing it, the starting spreadsheet that you have only has limited information. If you write this properly, you should be able to insert your program into something like this. Over time, you can export the actual AHS data and plot in the same way the current information. I have over here, so for that today's information, I actually inserted my solution. And I added the columns. The dates are going to appear here for each date, how many infections each day, how many people passed away. So what's this supposed to do? Writes the total cases, writes the text, the exact text, that's what's in quotes, total cases to I1. So we're going to have a label here. And then it's going to count the total cases, basically the number of rows where there's COVID information, all the way to the end. And then that appears in a pop-up. And then we'll write the information that's in a pop-up into the spreadsheet in cell J1. So we got the label total cases here, and then we'll have the actual number total cases here, and then a pop-up. So I'll stop at this point in explaining requirements, and I'll show what happens when you run these first, what they do. So we have, as of the data I downloaded December 2nd, in Alberta, almost 60,000 people have been infected, and that appeared in this pop-up for the second feature. In addition, we had that text total cases appear in cell I1. The final thing out of the first three features is we want to write that count that appeared in that pop-up, 59,484, appear in cell J1. We'll dismiss the pop-up and it'll appear. And we had some other things appear, which I'll talk about in a minute. So you have the date, had the total cases appear. The following two features I can also, the next feature I can describe. The two cells where the information written from the two of the previous features, this one and this one, bolded. Text is bolded, the text is bolded to highlight it. The data in the spreadsheet is sorted from earliest to latest. The hard-coded means that we have a fixed range. Say we only sort up to there. So we say from A3 as an example of a fixed range to K16. This more advanced feature, we basically figure out the number of cases that are in the spreadsheet, and we sort from the first case, the row containing first case, in this case, in this example, all the way to where we have data down to here. If we start deleting some of these rows, then it'll only sort up to here. So if we look at the order, the last, now it is in order, November 30th. We don't see other earlier ones. Now some of the later features. The date of the infection data. So we have the infection data here, and the dates are in this summary table over here, so we can eventually plot it. We only had one instance, because this is now in chronological order, one instance of an infection March the 6th, new infection, because there's one row here. The person recovered. It wasn't a person who passed away. And then on March the 9th, we have 1, 2, 3, 4, 5, 6 people who were infected. So we have 6 new infections. And in none of those cases, fortunately, did the person pass away. We do that for each one of these other dates. Notice that even though I have multiple rows, multiple people who are infected on March the 9th, we collapse all that information, and that's summarized on one row, rather than having one row for each instance. The other piece of data we count is the number of people passed away. In Alberta Health Services, so we have The first instance, apparently March the 14th. Alberta Health Services, to signify that, they use that text died. So you're looking for a particular date. March the 14th starts here. That's a person who passed away. March the 14th. There's no other people because now we're into March the 15th data. Only one person who died. And we have that information plotted. So the date and the infection. When we have an entry in a row, it signifies a new infection. We write this information, the dates, in column I. The next feature, the number of new infections are written into the rows of column J as we see. The number of people who passed away are written in the rows of column K. So now, feature number 9, what we're going to be doing is charting information about infections. This in itself, it has you might be able to see here, okay, we're in an increasing trend, but it's easier to see trends, to visualize them, if you actually have a graph or a chart. So we'll chart it, and that's what we had appear here. In this chart, we plotted basically time over the number of infections and number of people passed away. This can be done with 1 or 2 charts. In the spring, the number of infections wasn't significantly greater than the number of people passed away, so it fit in one chart. But now that we've got number of infections 1,700, the spread between the number of new infections versus, say, about, at most, I think we've had a dozen or 12 or 20 people pass away during that time. Again, I say at most, it's certainly not just a number, but just compared to the 1,700, it's a smaller number. It's harder to see, so I plotted 2 separate graphs. And that's what we have over here. So we have over here, we changed the title here, Alberta COVID Statistics, and we labeled this is for the new infections, this number of people passed away. And we plot over time the actual number of people who are infected. And we plot over time over here the number of people that passed away. Looks like the highest number of people passed away on a particular day was 12 so far. Hopefully it doesn't get beyond that. So feature number 9, you take this information and you chart it. So this gives you a overall view of what you need to implement, what my students in CPSC 203 needed to implement as an actual 200 level, which is first year for computer science at the University of Calgary, for non-majors. Especially impressive. So they're not people who want to write a computer program, they're plotting this information. And the thing about it is, what's being applied here is basic concepts that are taught in university post-secondary courses, even college courses, where you teach a little bit of program writing to even non-majors. Things such as using variables to store information, branching, ifs, while. But rather than writing a toy program that has, I don't know, grade information, something that isn't deal with a real world problem, hopefully to make this a bit more compelling, and perhaps hopefully students can actually continue using this if they're interested in plotting information for new COVID infections after semester's done. I decided to pick a real world problem, but I scaled it down so that it only included concepts that typically courses that are for non-majors that aren't all focused on programming, like this course that only have that only part of the semester includes programming. I scaled it down to only include concepts that were taught in similar such courses. It's just a more practical problem, hopefully a more compelling problem.